Okay, in this part, we will discuss on the DC analysis of a diode circuit. Okay, let's consider a very simple diode circuit consists of a DC source, 5 volt source, 5 volt DC source, maybe it's a battery, and then connected in series with a resistor with a value of 2.5 kilo ohm. And then in series connected in series with a diode. Okay. This is a diode, and then in ground. So we see here diode again. Diode is a symbol of diode. This is a positive anode terminal, and this line is a cathode negative terminal. Okay. The question is how to determine the ID, the current here, VD, voltage across the diode, and voltage drop at 2.5 kilo ohm. So this is the question. So actually we have two methods. One is the graphical approach. Another one is we need to replace a diode with a device model. Okay, in general, how we can solve this equation is, first, when you see this type of DC analysis, you should be able to write down the KVL, Kirchhoff voltage law. This is the one of the basic. So how you do the Kirchhoff voltage law, KVL? Okay, this is in series. Okay, so let's say you consider this current flow. So this current flow, the current is ID. So this is the current is ID. So we start from this one. Okay, so we have, this is a voltage, this is a voltage source. So the current here, the ID is from the exit the positive terminal. So when it's exit the positive terminal, so we put is negative, so -5. And then next is resistor. So usually resistor, this is, let's say we call it the voltage drop is VR here. This is positive and negative. So the next is the current flow is entering the positive. So the current flow is entering the positive terminal. So we have the positive VR. So VR is equal to ID times 2.5 kilo ohm. So we have this ID 2.5 kilo. Okay, so next is we arrive at the diode. So diode is, the current is entering a positive terminal. So we have this one is positive VD. So and the last one is ground, so equal to 0. So this is the KVL. So when you see the KVL, there are two unknown variable or unknown parameters. One is a ID, diode current, and another one is voltage, diode voltage, VD. So there are two variables. So if you want to solve this equation, you need to have another equation. At least you need to have two equations. This is equation 1. You have to another equation in order to solve I and D. Okay, so the equation actually come from, so you can have the equation actually come from the IV characteristic of the diode. So this is IV characteristic of the diode. So this IV, let's say this is ID as a function of VD. Okay, so if you remember in the previous slide, the ID of the diode, the current of diode, can be expressed using the exponential function of VD. So but now we just put a function here. So once you have these two equation, you need to solve the simultaneous equation 1 and 2 to obtain I and VD. So this is the general approach how you can get ID and VD. So once you get the ID, you can get the VR. Okay, first the graphical method to solve simultaneous equation. So in the graphical method, we use a graph. So this is the name of the method is graphical, means that you use the graph. So what we do is we have two equations. So you need to draw all two equations on the same graph. Okay, draw the line or curve from the equation on the same graph. So ID versus VD. Usually the second equation is the IV characteristic of diode is usually given or provided. Okay, next, when you have two line and curve, you need to identify the intersecting point. So the intersecting point is the point where the value satisfy all the two equations. So this is the solution of the simultaneous equation. Okay, for example, we already know given the IV characteristic of the diode. So for example, something like this. So the IV characteristic of the diode is given ID. So equation number 2, no need to draw because it's already provided. So but next, you need to draw the first equation. Okay, again, let's derive the KVL again. So the KVL is, we start from here and then the movement is here as the clockwise movement of current. So negative 5 volt plus ID 2.5 kilo ohm and then plus VD is equal to 0. So this is the KVL. So you need to plot this equation. Okay. When you examine this equation 1, you can tell that this equation 1 is a linear function. So it means that you should have a straight line because it's a linear function. So when you have the linear function, you only need to have 2 points in order to draw the line. Okay. So the simple approach is you make a table VD and ID, and then you calculate first when the VD is 0, you need to calculate the ID, and the second one you need to calculate the VD when the ID is 0. Let's say we calculate the ID when the VD is 0. So when VD is 0, so minus 5 plus ID 2.5K plus 0 is equal to 0. So ID is equal to 5 over 2.5K. So this is 2 milliampere. So the answer is 2 milliampere. Okay, this is the first point. Okay, the second point is calculation when the ID is equal to 0. So minus 5 plus, this is 0 times 2.5K plus VD equal to 0. So VD is equal to 5 volt. So this is a 5 volt. So you have here, you have 2 points. This is then when you have 2 points, you can draw the line. This is the line from the equation 1. This point is when the VD is 5 and ID is 0. And this point is where the VD is 0 and ID is 2 milli. So you have 2 points and then you draw the straight line. Okay, the answer is the intersection between this equation 1 and equation 2 is the IV characteristic of the diode. So the intersection is the solution. So you read the intersection point. So you know you can get the saturation point is around 0.75 volt and ID is 1.7 milliampere. Okay, this is you get the VD and ID. So in the previous question, you need to also calculate the VR, the resistor, the voltage drop across the 2.5 kilo ohm volt. So this is negative, sorry, this is negative. So once you get the ID, so the current across the 2.5 kilo ohm is equal to this current because this is in series. In series, the current is same. So you know the current and you know the resistance. So you can simply you can calculate the voltage drop across the resistor using the Ohm's law. So the VR is equal to the current is 1.7 milli, and then the resistance is 2.5 kilo ohm. So you get the answer is 4.25. 4.25 volt. So this is the answer. Okay. Regarding the load line, I want to add additional information. So when you have the load line is this red color line. Okay. This point, we have 2 points. This point we call it cut-off point. Cut-off point is where the current is 0. And this point is called saturation point, where we have the maximum current. Maximum current that is allowed in the load line. Okay, this is the point called saturation point. This is a cut-off point.